What if it's like 2 though? Like it's like down up and then you want to like switch an element or something like that. Yeah. Like what if it's 2, right? If it's down up, then what do we do? Okay, so I think we already proven that though, because like down up, you want to switch a bigger element to this. Like the act of switching a bigger element is always bad, right? Because if you were to switch a bigger element, then like that will mess up whatever that is, and then like there will be no bigger element inside the thing that can cover for that element itself, so it must be smaller. So then it must be we switch up and then whatever is down. So if okay, whatever is like the after the like first up elements, that means it will always get like a thing here, right? I think like okay, if we find the last mountain, then swap the element just before the with after that's after with the min valued element after with uh with any min value. Then sort everything after this element. This is going to min result satisfying q this and this. So how do we? So the main thing we need to do is sorting, essentially. You need to make sure everything goes in the correct like spot, I assume. And that can be achieved using like 2n comparisons, I think, with like that trick of like vectoring using yeah. So alright, so we will spend we will go from back to front, and at the time where we have a rising and a falling, then like if that's the case, then we just -1. Is it possible -1? Invalid queries 0 if PB -1. Screw queries no valid, print -1. Else print that. Okay, great. So we first get the n, right? Input the first line contains t, so which is what we have, and then we'll get n size permutation. Great. So we will go from back to front. So then for int size for we can just like how do I rev v as 0n. Whoops. Yeah. So rev v as 0n. Then what do we do here? Right. So what do we do? I'm not sure. Right. Right. Then we will say from and then we want to find like a increasing decreasing pattern. So we just want increasing. So if we first start with increasing, so let's just say int is 1, and then what? And then we're just gonna say if we're gonna query, what are we querying? IJ, right? Okay, IJ. So we're gonna query IJ and say if let's say I plus or query if let's just like do ask int q int x int y. So we're just gonna see out. What are we seeing? Outing. Okay, this format here. Int and sin and return and right. And then if like if ask or if ask, I guess if ask of I plus 1I is equal to a 0, which means 0 means what? What does 0 mean? 0 means that. So I is bigger than j here. Wait, okay, so we want to compare I and I plus 1, I suppose. Right. I and I plus 1. Okay. I and I plus 1. And if this is going to be equal to 0, then inc is equal to 0. Right. And then we want to find a value here. So inc is 1, or like, yeah, IDS is 1. So then we want to find the index. And then if inc is equal to 1, then p and then if inc is equal to 1, else, right? Else if inc is equal to 0, then we don't do anything. If inc is equal to 1, that means we're currently still doing some like increasing thing, which means that this should satisfy. Wait, 0 if, but it's never the case because it's permutation. Oh well, whatever, I don't care. Yeah. So this, right? And then what? And then what happens is that yeah, what happens is we want to do that. So we want to do increasing here, and then, you know, because it's increasing, right, then we don't do anything. But if inc is equal to 0, then I think we do something. So I'm not sure. Yeah. Inc is equal to 0. Sorry, yeah, inc is equal to 0. Yeah. If inc is equal to 0, then, you know, if inc is equal to 0, then we want to find when you know, it goes to 1 again. So if, you know, if let's see, inc is equal to 0, which means that, and then if ask of I plus 1 is equal to 1 again, then we just idx is equal to I, and then we break out in here. But 0 is bad, so you want, what do you want? I plus, no, you want, yeah, I guess 1, not too sure, yeah. Great, alright, so now you have this index, and then if idx is equal to, you know, -1, then we just see out -1 and 1, and then we just return. So, right, amazing. All right, cool. So now we have to, given this IDX, now let's say we've gone through n iterations. Now we have 2n left, which should be pretty trivial. Right. All right, 3n is very doable. Okay. So now we want to find the minimum number such that it is better than this. So we're gonna rep I0 or rep IDX plus 1, and then we're gonna rep n here, or n plus 1, whatever you want to call it. Right. So, all right. Let's just ask. So if ask of, you know, all right. So let's say the minimum value right here is what is the minimum value? Okay. So let's say the minimum value is like n or something like that, because there's bound to be a minimum value, and that minimum value is specifically, it must be it must be idx plus 1. So we're just gonna say int mn is equal to idx plus 1, and then we're gonna say this. So let's see. Let's see. Actually, oh, that's actually we need to do two operations here, which is really bad. Let's see though. Let us see. Oh no. Can we make this to one operation though? Because if we make this to one operation, then like we are forced to take. Okay, the break. We store breaking point actually. Use PR is equal to make one, I guess. PR is equal to IDX or like I or whatever. So we store the breaking point where I and I plus 1 is bigger than that. So after the breaking point, everything else should essentially just be like right. We don't need that. Okay. If ask of you know I and 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 what are we doing? If ask of I and what is it called? Well, no, ask of IDX and I, right? IDX and I, which is like after the breaking points. After the breaking points is equal to a like if this such that this is bigger means it is going to be equal to 0. That means I is bigger, which means that we want I to be our min value. So, or like IDX plus 1 here. I guess we can just say min is equal to I. Min is equal to I, right? And then after the breaking point, n or like n plus 1 or whatever, right? this